Okay. Now we will start with metallic glasses. Okay. So among all these materials, 7 classes of materials, what you should know is the definition for these materials. Okay. So what are these materials, and in some parts, how these materials are prepared. Okay. And then if there are different types, you should know what are the types of that materials, and then the properties, and then the applications. Okay, so these are the general topics you should be knowing. And on some materials you don't have to know about the preparation method. And in most of the materials, the 3 most important parameters you should be knowing about on this unit is what are those materials, that is the definition for those materials. Okay, and then the properties of those materials. Okay, so why these materials are important, and which property makes these materials important, and then where they are applicable, where they are applied. So these are the things you should be knowing about these 7 classes of materials. Okay, so let us move to the next uh, part. So metallic glasses. Okay, so here I have given some of the figures used as a metallic glasses, metallic glass ribbon, and then some titanium based metallic glasses. And then here you have for biomaterials, these are the uh, metallic glasses used for hip joints. Okay, so as I said before, you should know what are metallic glasses. In general, metallic glasses are briefly called as MGs. Okay, so metallic glasses. Sometimes in the question paper also they will give as a MG. Okay, and then for shape memory alloys, SMA. So you should know these abbreviated forms also. Okay, so we are going to see what are metallic glasses. We are going to see how these metallic glasses are prepared, and then as I said, we are going to see what are the types of metallic glasses, and then we are going to see the properties of the metallic glasses, and finally we are going to see some of the applications where the metallic glasses are used. Okay. So let's first start with what are metallic glasses. So in the last semester, I think we have studied about in the 5th unit when you study about crystal physics, we have studied about the crystalline materials and then the amorphous materials. In crystalline materials, the atoms are regularly arranged in the 3-dimensional pattern, and they have the properties are anisotropic. That means the properties are different in different directions, and most of the metals are in fact all metals are crystalline in nature. For example, take iron, titanium, nickel, whatever metal you take, those are all in nature, they are all crystalline. That means their atoms are regularly arranged and they have anisotropic properties. In amorphous materials, the atoms are not regularly arranged and they are randomly oriented. Okay. And in glasses, we have a specific properties. That means amorphous are known as glasses. Okay, so there are different types of glasses. The common glass which we are using is the silicon glass. That means the amorphous silica, which is quenched. The atoms in glasses are like the atoms in the liquid phase. It is like a liquid phased, frozen liquid phased solid. That's what amorphous is. Okay, that means these atoms, individual atoms, will not have interaction, not a strong interaction with each other. That is the property of amorphous materials, and glasses are one of the amorphous materials. They have some properties. We are going to see that. For example, they are strong. They don't have the crystal boundaries. In crystalline materials, we used to have the crystal boundaries. We have studied about that in polycrystalline materials, and even in single crystalline materials, we used to have defects, boundaries, all these things. In amorphous materials, we can avoid those things. We can avoid the grain boundaries. We can minimize the defects, all those things. The metallic glasses. Okay, so what will happen if you mix these two types of materials? Okay, the properties of crystalline nature materials and then the properties of amorphous glasses. So that will give the metallic glass, a type of a new class of materials called metallic glasses. Okay, so which has both the advantageous properties of crystalline materials and the amorphous materials. Okay, so those materials are called as metallic glasses. Okay. So now let's see how these materials are prepared. Okay, so as I said before, so you should be knowing about the preparation method. Okay, so the metallic glasses can be prepared by different methods. One is called as a melt spinning method. Okay, so melt spinning method, and this is twin roller system. Okay, it's not there is a spelling mistake here. This is a twin roller system, and then metal extraction system, and then this sputtering system. So you can prepare metallic glasses by different methods. In all these methods, the procedure is very simple. So you melt the method, you melt your solid material, and when it is in a melt, that means it is in the liquid state. Okay, molten state. This is in the liquid state. Okay, so you if you give atoms to arrange itself in a regular manner, then it will form a crystalline phase. Okay, so don't give that time to arrange the atoms by itself to form a regular structure. So if you quench it, that means if you cool the melt suddenly, then the atoms will freeze in the molten state itself. Okay, so that is called as, then you will get a amorphous material. Okay, metal which is crystalline in nature, you have melted it in a molten state. The atoms are in the liquid nature, so you are freezing it in the atoms on the molten state. You are not letting the atoms to arrange itself, and then the atoms are frozen in the liquid state. That means that those are all amorphous materials. So you have okay. There is a network problem, so it may disconnect a couple of times. My network is not that much good. Okay, so just bear with me. Okay, so this is how you can prepare the metallic glasses, and this is the actual instrument by which you can prepare the metallic glasses. Okay, so you see this is the refractory tube. This is how you are going to draw in your exam. Okay, so this is the refractory tube here, and then this is the heater, so that you can melt your metal, and then this will be in the liquid state, and here is a roller. So this is the melt spinning method. Okay, okay, I think to me. Okay, fine. Okay, so this is how you can prepare your metallic glasses. Okay, so you have a refractory tube, and you have a heater, and you have a condenser. Okay, so this is like a rotating roller where the temperature is very low. You can cool this. You can pass a cool chill water. So here the temperature will be in thousands of degrees, and here the temperature will be like a few tens of degrees. So you are cooling from 1000 degree to few tens of degrees. So that means you are not giving the atom to arrange itself. So you are freezing the atoms in the molten state. So by this method, you can get metallic glass strips, ribbons, like these kind of things. Okay, so you can prepare metallic glasses. So we are in couple of slides, we are going to see how these metallic where these metallic glasses are used. Okay. So there are two types of metallic glasses. One is called as metal. Okay, so there are two types of metallic glasses. One is metal glasses, and then another one is metalloid glasses. It depends on how you are preparing these metallic glasses. If you combine two metals, then it is called as metallic glasses. That means you are combining nickel and niobium, magnesium and zinc, copper and zirconium. All these are metals. So if you combine the two metals and prepare a metallic glasses, then it is called as metallic glasses. Okay. So if you combine a metal with another metalloid, which is a non-metal, then it is called as metalloid glasses. For example, iron, cobalt, nickel are all metals. If you combine this with the metalloids like boron, silicon, carbon, phosphorus, these are called as metalloids. So if you combine metal with a metalloid, then those are called as metalloid types of glasses. So they have a different applications. For different applications, you need a different combinations. Okay, so let us move to the properties. Okay, the structural properties, the metallic glasses are different from the metals, in which they are having tetragonally closed pack structure. In metals, pure metals in general, they will be having a hexagonal closed pack structure. Here, for metallic glasses, they will be having a tetragonal closed pack structure. This will be advantages, and as I said, the defects are low. Okay, so the grain boundaries and dislocations we can minimize, or you can completely nullify the grain boundaries and dislocations if you prepare a very good metallic glasses. Okay, how these metallic glasses are better in mechanical properties? They are having high strength. Okay, mechanically strong, because they don't have grain boundaries and defects. Okay, so that will be strengthen their mechanical property, and they have very high corrosion. Okay, this is one of the major problem in the industries where the metals are used. The corrosion, the metal will get corroded. Okay, it will get oxidized. You see some iron instrument used with iron, not a proper steel, or even and steels, it will get corroded. Okay. So if you have a to avoid that corrosion, we can have these metallic glasses. Okay. So they have high elasticity. In metals, in pure metal, this is not possible. It is not elastic nature, and that's plastic in nature. Your metals are plastic in nature. You cannot bend it too much. Okay, but metallic glasses are elastic in nature. Okay, and then elastic, the metallic glasses are ductile and malleable. Okay. And then the magnetic, coming to the magnetic property, the metallic glasses are soft magnetic materials. Okay, so in the last unit 4, we have studied about the soft magnets and the hard magnets. The hard magnets, you can use it for memory applications, core memories, and then the soft magnetic materials, you can use it for transformer cores. Okay, so the metallic glasses are soft magnetic materials. So like this, the hysteresis loop will be like this. So you will be having a very small loss in loss. Okay. Okay, so we have a very small loss. So these can be used for transformer purposes. As they are soft, they can be magnetized and demagnetized easily, and they exhibit very high saturation properties. Okay, so these are the magnetic properties for soft magnetic materials you have studied already. Okay. Coming to the chemical properties, they act as a good catalyst because of the amorphous state. Okay, and then the electrical properties, they have a very high electrical resistance, and then the electrical resistance will not vary with the temperature because they are amorphous, and they possess very low eddy current losses. Okay, so I I think this will disconnect in a few minutes because I think I have passed half an hour. We will start again after if it disconnects. Okay. So we will see some of the applications for metallic glasses. As I said before, as they are soft magnetic materials, they are used as cores for high power transformer materials. They can be used as a filament winding to reinforce pressure vessels, uh, to produce different kinds of springs by which you can avoid the corrosions. Okay, and then you can use for nuclear reactors again to avoid the corrosion by radiation effect, and and they can be used to produce high magnetic field, and they can be used in tape recorder and magnetic shields also. Okay, coming to the second class of materials. Okay, so I will just disconnect and then uh, connect again. Okay, so this is going to uh, uh, disconnect. Okay, we have 5 more minutes of it, we will see. Uh, okay, so the second class of materials is called as shape memory alloys. As I said before, we are going to see what are shape memory alloys, and then preparation is not needed for shape memory alloys. For your case, it is not given in the syllabus. Okay, so we are going to see the types of shape memory alloys. What are the types, different types of shape memory alloys, and then we are going to see what are the properties of shape memory alloys, and then finally we are going to see some of the applications of shape memory alloys. And here I have given a figure where we can use for orthodontic purpose. You can use these shape memory alloys when the dentist previously they used to put a metal clip to arrange your teeth. So when you put a metal teeth, the doctor will advise you that you should not take hot or cold food items because the metal will deform. Okay. At least for some time. Okay. But when you put a metallic shape memory alloys, you can take a whether hot or cold food because shape memory, as the name implies, it remembers the shape. Okay, it memorizes the shape. Okay, so you change the temperature, it will come back to its original shape. That's called as shape memory. Okay, it's alloy. The name says it is prepared by mixing different metals, two or more metals. Okay, so now we will see one by one. Okay, let's see what are shape memory alloys. As I given here, shape memory alloys are alloys, that is a combination of metals which remembers its shape by heating or cooling. Okay, that means these are a very excellent or interesting class of materials. It has a very good applications, excellent applications, especially for biotic people like you. We will discuss that in later. This depends on how the atoms are arranged. Okay, so these different memory, shape memory, depends on how the atoms are arranged. So there are two types. Okay, two types how the atoms are arranged. One is called as martensite and another one is called austenite. Okay, so at the low temperature they will have the martensite structure. So the atoms are arranged like this. Okay, so that is something like twisted, okay, twisted tetragonal or a cubic structure, twisted cubic structure. In the high temperature, this will have the austenite structure. Okay, so this is the atoms are arranged like this. So if you change the temperature, that remembers the atom position. That will come back to the atoms will come back to its original position. So that's how it remembers the shape of that material. Okay, so here I have given a link. We will try at the end of this presentation whether this is working. Okay, so if you click this, that should go to the YouTube. This is a MIT page that gives uh, uh, excellent video about how these uh, shape memory alloys are working. Okay, we will see this video at the end of this lecture, but not now. I will upload this video in the Google Classroom, in the new Google Classroom. You can watch that. And then the types of shape memory alloys. There are two different types of shape memory alloy. That is, one is called as one-way shape memory alloy, and another one is called as two-way shape memory alloys. In one-way shape memory alloy, it remembers the shape in one way, whether it is either on heating or cooling. On only one way, it remembers its shape. Okay. On two-way shape memory alloys, it remembers its shape on both the ways, both on the heating and on cooling. That's what is called as two-way shape memory alloys. Here are I have given examples for different shape memory alloys. Nickel titanium alloy, one of the well-known, well-studied, excellent shape memory alloy. In your syllabus, they have given this as a separate topic because this is such an important shape memory alloy. And another one is copper, aluminum, nickel, calneo. Okay, so and then copper, zinc, aluminum. Okay, if you see in all these things, they have mixed two different or three different metals to prepare an alloy, okay, to have this shape memory alloy. Okay, so the time is going to end now. The 40 minutes of this Zoom time. So we will disconnect now, and I will connect back maybe in 5 minutes. Okay, now the time is 10:03. I will join you back on 10:10. Okay, in 5 minutes you can take a break of 5 minutes. We will join back on 10:10. Okay, take a break for 5 minutes.